Now that we have looked at what happens if you have, after differentiating, if you differentiate and get du equaling to something with an extra number that's not present in your original expression. Now we want to look at what happens when after differentiating and du equals something, and after differentiating you have some extra variable still in your expression. So extra constant I can pull out front, no problem. Extra variable, what do I do now? So I'm going to show you by going through this example. So I noticed right away that I cannot distribute this x in because of the square root, so I cannot change this to a polynomial. So since I can't change it to a polynomial, I'm going to try to use some u substitution. So I'm going to go ahead and try letting u equal my expression underneath the radical x minus 1. Well, I know that that's going to allow me to substitute here. I want to be able to substitute this dx because remember I can't integrate with a u and then a dx. So figuring out what du dx is by differentiating both sides of this expression here in terms of x, I get du dx equals 1, which means du equals dx. Well, that allows me to put u in for x minus 1, and it allows me to put du in for dx. So doing that, my new expression is going to become the integral of x, the square root of u, du. Well, notice this causes a problem because now I have x and u du. I need to do something with that x. So if I start trying to figure out something to do with the x, I notice that right here I defined what u was. Well, if I added a 1 to each side, that would become u plus 1 equals x. The reason this is helpful is because if I put this u plus 1 in for this x, my integral will be in terms of u's only. So I'm going to go ahead and do that, giving me the integral of u plus 1, the square root of u, which is the same thing as u to the 1/2, du. Well, now I can integrate this, but before I integrate it, I have to get rid of that multiplication because, again, I don't have any kind of a product rule for integrating. So I'm going to distribute that u to the 1/2 in, giving me the integral of u times u to the 1/2 is u to the 3/2, plus 1 times u to the 1/2 is u to the 1/2. And now I'm ready to integrate. So when I integrate this, I end up with 1 over 1 plus 3 over 2 u to the 1 plus 3 over 2. Plus 1 over 1 plus 1/2 u to the 1 plus 1/2 plus c. Cleaning that up, I get 1 over 1 plus 3/2 is 5/2 u to the 5/2 plus 1 over 1 plus 1/2 is 1 over 3/2 u to the 3/2 plus c. From here I'm going to go ahead and say dividing by 5 over 2 is the same thing as multiplying by 2 over 5. Dividing by 3 over 2 right here is the same thing as multiplying by 2 over 3. So I'm going to do that. I'm also going to put x minus 1 back in for u, giving me 5 over 2 times x minus 1 to the 5/2 plus 3 over 2 times x minus 1 to the 3/2 plus c. And that will be my final answer. Moving on to example 2. I'm going to go ahead and work this the same way. First, I check to see if I can integrate it as written. Because I have multiplication here and I do not have a product rule for integrating, because I cannot distribute that in, I'm going to have to try another option. So I'm going to go ahead and try again that u substitution. So doing that, I'm going to let u equal my x minus 1. Well, that means du dx must equal 1, and du must just be dx. Well, if I go ahead and plug in du for dx and u for x minus 1, my new integral becomes x squared times the square root of u times du. So again, I'm running into the same problem I did in the last example. I cannot integrate with both x's and u's. Something has to change. Well, I know when it was in terms of x's, there was nothing I could do. This was not, I could not integrate this as written. So instead, I'm going to go ahead and say, can I change this x squared to be in terms of u? Well, if I look at right here, I've defined what u is. So couldn't I just add 1 to both sides and say that x is just u plus 1? And then knowing that, couldn't I take that u plus 1 and put it in for the x squared, or putting it in for the x, thus allowing me to be taking the integral of u's only? So I'm going to go ahead and do that. And now I have the integral of u plus 1 squared times the square root of u, which is just u to the 1/2, du. Now I'm able to integrate. I still do have to do some work because, again, I do still have this function here that is not in complete polynomial form because of the square, and I also have this function out here. So I'm going to go ahead and FOIL this, and then I'm going to distribute u to the 1/2 in. So doing that, I do get the integral of u plus 1 times u plus 1 is u squared plus 2u plus 1 times u to the 1/2. If I then distribute the 1/2 in, I get u squared times u to the 1/2 is u to the 5/2 plus 2u times u to the 1/2 is 2u to the 3/2 plus 1 times u to the 1/2 is u to the 1/2. I'm now ready to actually do my integrating. So when I integrate, I come up with, I'm going to move my work down over here. I end up with 1 over 1 plus 5 over 2 u to the 1 plus 5 over 2 plus 2 times 1 over 1 plus 3 over 2 u to the 1 plus 3 over 2 plus 1 over 1 plus 1/2 u to the 1 plus 1. Thus giving me 1 over 7 over 2 u to the 7 over 2 plus 2 times 1 over 5 over 2 u to the 5 over 2 plus 1 over 3 over 2 u to the 3 over 2. From here, I am now able to go ahead and say dividing by 7 over the 2 is the same thing as multiplying by 2 over 7. Dividing by 5 over 2 is the same thing as multiplying by 2 over 5. And dividing by 3 over 2 is the same thing as multiplying by 2 over 3. I'm also then able to go ahead and take this x minus 1 and put it back in for my u's, giving me a final answer of 2/7 times x minus 1 to the 7 over 2 plus 4/5 times x minus 1 to the 5 over 2 plus 2/3 times x minus 1 to the 3 over 2, finishing my problem. I should also, before I add on my plus c, which I should have been adding on and carrying throughout my problem, so I do apologize for that. Looking at one final example. This will be very similar to the first example. If you feel like you understand this, feel free to skip listening to this third example. If you think you're getting it but you're not sure, now would be a good time to press pause and try to do this problem on your own and check to see how you did. So go ahead and press pause now if you would like to do that. Okay, and I'm going to go ahead and go over how to do this. So the first thing I'm going to do, I have two options here. One of my options is I could square this, distribute my x in, and then go ahead and integrate it. But showing you that I can use my u substitution for it, going through that extra practice with that process, I'm going to go ahead and let u equal x minus 4, and then du dx does equal 1, meaning du once again is just the dx. So plugging in, I do get the integral of x times u squared du, again giving me this extra x that I need to do something with. So taking my definition of what u is, I'm going to go ahead and add 4 to each side, and I do get u plus 4 equals x, allowing me to put this expression here in for my x. Doing so then gives me the integral of u plus 4 u squared du. Before I can go ahead and integrate, I do have to get rid of that multiplication, so I am going to distribute my u squared in, giving me u cubed plus 4u squared du, and now I'm ready to integrate. So going ahead and integrating this problem, I see that my u cubed does become 1 over 1 plus 3 u to the 1 plus 3 plus 4 times 1 over 1 plus 2, u to the 1 plus 2, and plus c, giving me 1/4. I am going to go ahead and plug in x minus 4 for u. X minus 4 to the 4th plus 4 times, this is going to become 1 over 3, so 4 over 3, again plugging in x minus 4 for u to the 3rd, plus c for my final answer.